In part one of square root functions, we learned about what a square root function is and basically how to graph it. In part two, we're going to go a little more in depth, learn about what the parent function of a square root function is, and then see the general form of the transformations for square root functions, find out what each part does, and how that affects our graph. So, with that said, let's look at a parent function of a square root function. This is the parent function for square root functions. It is y equals the square root of x. It's considered the parent function because this is the most basic version of a square root function. And what makes it the most basic version? All we have is a square root symbol and x. There's nothing else happening to it. So since we have just those two pieces, it is the parent function. All other square root functions are based off of this function right here. Now, as I said, we have some transformations. The transformation formula is going to look something like this. We start off with y equals a times the square root of x minus h plus k. And that's a whole lot of stuff right there. And each variable, a, h, and k, changes our graph just a little bit. So we're going to go through some examples and see what does h do, what does k do, and then what does a do. So without further ado, let's take a look at an example that deals with h. Alright, so we have our parent function right here, which we're going to graph first just to see what that looks like. Then we're going to graph our new function over here, which is the y equals the square root of x minus 3, and we're going to see what happens. So when I'm graphing this, I want my x to be perfect squares, which will make things work out much nicer. So first I'll put a point at 0, because square root of 0 is 0. Put a point at 1, square root of 1 is 1. Then I'm not going to put anything at x equals 2 or 3, because those aren't perfect squares. And I'm going to go to x equals 4. Square root of 4 is 2. And that's the last one that'll fit on my chart. But if I connect them, you'll start to see the general shape. This is y equals the square root of x. We can graph this one just the same, but remember, we want to make sure that what's under the radical is a perfect square. And since I'm subtracting 3, I have to be more careful. If I put 0 in for x, well, 0 minus 3 is negative 3, and now I have an imaginary number. So I have to be careful. First of all, what is going to make under here 0? Well, x has to be 3, so I'm going to put my first dot at x equals 3. 3 minus 3 is 0, we're good. Now the next perfect square is 1. What does x have to be to give us 1? Well, it has to be 4. 4 minus 3 gives us 1. And then the next perfect square is 7. Oops, not 7, 4. X has to be 7 because 7 minus 3 is 4. And that sort of falls off our chart just a little bit. It's going to go right there. And our graph is going to look something like that. Here is y equals the square root of x minus 3. So what do you notice about these two graphs? The parent function starts at 0. The new function, x minus 3, starts at positive 3. So we can say that anything underneath the radical with x shifts our graph either left or right, and it's based off the opposite of the sign. If this is negative, we're going to go into the positive territory. If this is plus 3, we're going to go into the negative territory. As I can show you right now, if we had y equals the square root of x plus 3, well, once again, I need to make this 0 underneath. Well, that's going to start us at negative 3. Then, if I want it to be a positive 1 underneath, I got to go to negative 2. And if I want it to be a positive 4, I have to be at 1. And with this one, I actually could get it up to 9 if I put a 6 there. So then my graph goes even further. And this would be y equals the square root of x plus 3. So if we go back to what our original form looked like that I showed you a moment ago, let me erase this and put it back up. We had y equals a times the square root x minus h plus k. H shifts the graph left or right depending on the sign. If it is negative or subtraction, we go to the right. If it's positive, we go to the left. So that's what H does. Now, let's try something that has K. Alright, this time we still have our parent function, which I've already graphed for us to save time. And I have two transformations. First, it's the square root of x, the parent function, plus 2, which is not under the radical. And then we also have the parent function, the square root of x, minus 2, which is not under the radical. This is a little bit simpler, takes some of the guesswork out, because since the only thing under the radical is x, we can strictly use our perfect squares, 0, 1, 4, 9, and so forth. So if I started at 0, x equals 0, square root of 0 is 0, but then I have to add 2. So that's going to mean my x is 0. I'm going to stay at the origin, but then I have to shift up 2. So my first point will be at the coordinate 0, 2. Now if I use the next perfect square for x, which is 1, 1 plus 2 gives me 3. And then when I go to 4, the square root of 4 is 2. 2 plus 2 gives me 4. And as you can hopefully see, you get the exact same graph as y equals the square root of x. You have just shifted it up 2 units. So we got y equals the square root of x plus 2. Anything outside of the radical that you're adding or subtracting either shifts it up if you're adding, and you can probably guess if it's subtracting, you're shifting it down. So for the green function right here, I can use all the same points that I did before, but I'm going to subtract 2 from them instead of adding 2. So if x is 0, square root of 0 is 0, minus 2 gives me negative 2. Then when I go to 1, square root of 1 is 1, minus 2 is negative 1. And when I go to 4, square root of 4 is 2. 2 minus 2 is 0. So I have the exact same graph again. The only thing different is the fact that it is shifted down from the parent function 2 units. Very good. So what can we say about our transformation formula? Let's put that up again. Y equals a times the square root of x minus h plus k. K shifts our graph up or down depending on the sign. Up if it's positive, down if it's negative. And then remember h shifted the graph left or right. Left if it was positive, right if it was negative. Alright, and then that just leaves us with this pesky little a to deal with. So we'll move on to that next. Alright, now we have our parent function still, which I need to graph. Give me a moment, sorry. There we go. There's our parent function. Y equals the square root of x. And this time we have a value for a. A can be an integer, or it can be a fraction or a decimal. So let's see what happens. I purposely left what's under the radical as x to make it as simple as possible. So I've got the square root of x, which means I can use all my perfect squares. But after I get this, take the square root, here I got to multiply it by 2. I got to double it. Here I got to cut it in half. So let's see what that does to our graph. If x is 0, the square root of 0 is 0, and 2 times 0 is 0. So we still start at the origin. If x is 1, square root of 1 is 1, but 1 times 2 is 2, so I go up to there. Then I've got 4. Square root of 4 is 2. 2 times 2 gives me 4. So what you're hopefully noticing is I have the same basic shape, but it's opening up wider. Look at the distance between the x-axis and the magenta graph for the parent function, and then look at the distance between the x-axis and the neon green graph, and it's a bigger difference. The graph is opening wider. It's going up faster. So if a is a whole number, our graph becomes wider. It goes up in the y values faster than before. So you can probably take a guess as what happens when it's a decimal or a fraction. It's still going to start off at the origin. So square root of 0 is 0, 0 times a half is 0. But then if I put it at 1, square root of 1 is 1, but 1 times a half is a half. So I'm actually going to be between 0 and 1. Then when I move to 4, square root of 4 is 2. 2 times a half is 1. So I'm going up much slower. My graph is actually narrower than before. So A determines how wide the graph opens up. If it's a whole number, it's wider. If it's a fraction that is less than 1 but greater than 0, it's going to be narrower. So let's wrap this all up. Here we have our two main formulas that we've been working with. We have our function, our parent function right here. So let's make sure we remember that this is the parent function, because from this parent function all the other permutations can be created from. And then we have our transformation versions, which has all the little bits and pieces. Remember, A determines how wide or narrow the graph becomes. H shifts the graph left or right. And we can say it shifts it right if subtraction, left if addition. And then lastly, we've got K shifts it up or down up if positive or adding, down if subtracting. And there you have it. Everything else about our square root functions that we learned in part 1 still applies, especially our domain and range. So if you need a refresher on our domain and range, feel free to look back at part 1 of our square root function videos. Otherwise, now we've learned all about the different ways we can transform the parent function. Hope you found this helpful, and good luck.